Let's go through LeetCode 857, minimum cost to hire K workers. So there are N workers, and you have two arrays, quality and wage. You want to hire K workers, and we need to meet two conditions. That is, every worker, they need to be paid their minimum wage expectation. So this wage array is the minimum wage expectation. And also, every worker in the paid group should be paid in the ratio of the quality. So that means if we hire K workers, they should have the same wage divided by quality. That is the ratio, right? We call this ratio. So if we hire K workers, the ratio should be the maximum of this K ratio of this K worker, right? So that everyone so that everyone the wage they will meet. And also the because the ratio is the same for all of these K workers. So what we're thinking about is that we should so in order to keep the total salary or total cost lowest, right? So there are two kind of variables. One is quality, right? Quality. The person we select the K workers, and so we know the worker who pay the most is the one with which the largest quality, right? Another is the ratio we would like to pay this kind of worker, right? So we want to keep the quality as small as we can, and also we want to keep the ratio as small as we can, right? So the things that there are two variables, and what we thinking about is that possibly we fix one variable. For example, we sort the workers by the ratio, right? And also use that structure to check another variable, right? Every time, so we select the K workers, possibly the K smallest ratio workers. So now the optimal solution for us, because if we remove a worker out, it's a worker with the largest quality because it has the largest cost, right? So in this case, for example, we want to remove the largest quality worker, right? And then we can add a worker with the ratio K plus 1, right? Or whatever this index or the K plus 1 biggest worker, right? But it's possible its quality gets smaller. So the total cost so maybe smaller, right? So in order for every worker, right, we get the largest quality. So we should use the max heap to maintain the quality, right? There is some kind of details we need to consider about. So we know for the workers, they need to sort by ratio, right? So if two workers, they have the same ratio, right? So we should move to the collection, the smallest quality. So the first, we need to compare by ratio, right? If ratio equals, then sort by quality. So that is in ascending order, right? So the same thing here, right? The quality, if there are two workers, they have the same quality. So what kind of I work J, right? They have same quality. What kind of worker we should move out? Of course, we should move out the one which have the largest ratio, right? The biggest one, right? So from so we need to sort in 2 dimensions. That is the ratio quality, and this kind of data structure we should also have use a priority queue for the max heap in quality ratio, right? First of is quality, second is ratio. So in this case, so let's begin to write code for this, right? So let's have 8 equals quality dot length, and we need to compose another array called workers equals new int and and 2. Okay, so for int I equals 0, I smaller than int I plus plus, we know worker I 0 will be the quality I, yeah, right. And the workers, let's call it, this is workers, workers I 1 will be the wage, right? So for the sort by ascending order, that is arrays sort workers, right? So we'll say worker A and B. So so let's say private double ratio worker, right? Because 1.0 multiplied by wage, right? So that's a worker 1 divided by worker 0, right? So if get a double, get a ratio A equals get a ratio B, then we'll have the quality, right, to be we'll use that, we'll select into our priority queue the smallest quality, right? So integer compare A 0 B 0, right? Otherwise we just double compare, right? Double compare. So we are first compare by its ratio, then by its quality, right? So both in ascending order. Okay, so this will be how we sort the workers, right? And then we needed to have a priority queue, right? To have k max heap to have the k workers. Priority queue and worker sorry, just this one, right? We should have a max heap, new priority queue. We can have size k plus 1 should be fine, right? K plus of 1. And so this is that we have the quality, compare the quality first, right? So that will be A, B goes to if A 0 equals B 0, right? That we are going to pop up the Harris ratio, right? 1. So will be double compare with the ratio B with the ratio A, right? If otherwise we should have an integer compare, right? Integer compare B B 0 A 0, right? So let's have the result double result equals double but max value, right? Max value. Then what we going to do is that we try to iterate for every workers, right? For this worker and workers, right? So they already sorted. So we also need a quality, right? Quality in total quality, right? So quality total quality equals 0, right? So what we need is our max heap should add, right? Add a new should add this worker, right? Worker. And also what's the total quality should add this worker 0, right? And I will say if max heap dot size is greater than k, right? Then we need to remove one, right? We need to have total quality minus equal to max heap 4, right? 4 it and get its quality, right? So when if the max heap size is k, right? We should compare with the total result. When the size equals k, then we're going to have a result equals mass dot main result. Of course, we also needed to when we add we should so when we add this worker, right? So its ratio is this worker's ratio, right? Get ratio. So let's call it get ratio instead of get ratio. Worker and multiple by total quality, right? So in the end, we just needed to return result. Let's try and see. Oh, wait, so this one's called get ratio. What is this? Let's get rid of this now. So integer compare total add should this is integer, should plus equal to plus equal to, and this is minus equal to. Okay. Okay, so doing like this, right? We have a sort. This is n log n, right? And we have a priority queue, right? This priority queue, that is log k process, right? So here that is n log n. So this is k n log k, right? So total time complexity, the k is smaller than n, right? So it will be n log n, and space is linear O n.